Hello students and welcome back. Yesterday we were doing conductivity cell and today we'll discuss electrolytic cell, the second part of electrochemistry, and in the next lecture we'll discuss electrochemical cell. So let us begin this electrolytic cell. So what is electrolytic cell? Electrolytic cell is a cell which uses electrical energy to drive a non-spontaneous reaction. A non-spontaneous reaction is a reaction which will not occur by itself. So it will need an external force in the form of electrical energy. So what is electrolytic cell? Electrolytic cell is a cell which uses electrical energy to drive a non-spontaneous reaction. And this process of driving a non-spontaneous reaction with the help of electrical energy is called electrolysis. And that will be the focus of our discussion today. So we can divide electrolysis into two parts. We can perform electrolysis either with the help of inert electrodes or with the help of active electrodes. Inert electrodes are the electrodes which will not react in the process, they will not get consumed. Normally we use graphite and platinum in the form of inert electrodes, but active electrodes, they will react in the process and they will get consumed also. Further, we can divide the electrolysis with the help of inert electrodes into two subcategories. We can perform electrolysis of molten salt and electrolysis of aqueous solution of salt. In molten salt electrolysis, only the ions of salt will go for electrolysis. I mean that cations will go to cathode, anions will go to anode. There is no competition out there. But in case of aqueous solution of salt, cations and anions will also compete with water to go for cathode and anode. Who will win and who will get reduced and oxidized? Let's see in the further discussion. Okay, so we'll begin the discussion of electrolysis of molten salt. So students, let's see certain examples of electrolysis of molten salt with the help of inert electrodes. So we are taking certain cases which are important from the point of view of NEET. So the first case is molten NaCl. So when you say molten something, it means in the liquid form. On heating, when the salt melts, it's called molten salt. So molten NaCl will contain Na plus and Cl ions, cations and the anions. Remember that in the case of electrolysis, anions will go to anode, anode is positive electrode, and cations will go to cathode, cathode is negative electrode. Remember that at anode always oxidation will take place and at cathode always reduction will take place. So over here, who will go to the positive electrode? The negative charge particle, that is the anion. So anion goes to anode. So here oxidation will take place. Oxidation means losing electrons. So these Cl ions, they will lose the electrons. They will lose 2 electrons. These 2 electrons will travel all the way and they will be captured by Na plus. So Na plus will accept 2 electrons to become sodium. So in this case, sodium will be deposited at cathode while chlorine gas will be evolved at anode. They ask you question like which gas will be evolved or which element or which particle will be evolved at anode and cathode. So in this case the answers are Cl2 and sodium. Let's take one more example, molten calcium hydride. Now over here you need to remember that in the case of metallic hydrides, in general hydrogen is more electronegative, so it will be H negative, metal will be cation. Anion goes to anode, cation goes to cathode, and here at cathode reduction will take place, at anode oxidation will take place. So H negative will lose the electrons, these electrons will travel there and will become calcium. Calcium ions will accept electrons to become calcium. H negative hydride ions will lose electrons to become hydrogen. So here hydrogen will be evolved at anode and calcium will be deposited at cathode. Okay, now see molten K2SO4, important case, bit special case. So K2SO4 will give you sulfate as anion and K plus as cation. So at anode, sulfate will oxidize, it will lose 2 electrons to become S2O8, 2 negative. Very important, very important. They ask you what is the product at anode in the case of K2SO4. Also these 2 electrons travel all the way to cathode where K plus will capture them to become potassium. So potassium will be deposited at the cathode. Let's take a couple of more examples, then it will be more clear. So let us take the example of electrolysis of molten alumina, Al2O3. This will give you aluminum ions and oxide ion on melting. Now here we use carbon electrodes. In the previous 3 examples, we used platinum electrodes. So over here what will happen? Oxide ion is the anion, it will go to anode, and at anode it will try to discharge. But over here just remember that carbon is not acting as an inert electrode. Okay, so this oxide ion have a great affinity towards carbon. It will form CO and 2 electrons will be released. If oxygen is present in the excess amount, then it can also form CO2 and releasing 4 electrons. Total 6 electrons will be released, and they will be traveling across the anode towards the cathode, where 2Al3 plus will accept these 6 electrons to become aluminium. So in this case, aluminium will deposit at cathode, and 2 gases, carbon monoxide and carbon dioxide, will be evolved at anode. Very important, they ask you which gases are evolved in the case of electrolysis of molten alumina. People sometimes answer O2, but the answer is actually CO and CO2. Okay, we use carbon electrodes, very important. Again here, molten Na2S2O3. Now this is called sodium thiosulfate. It will dissociate to give you S2O3 2 negative ion and Na plus. This will oxidize, donating 2 electrons to become tetrathionate ion, and these electrons will travel all the way towards cathode, where sodium ions will accept the electrons and will become sodium. So sodium will be evolved here, and tetrathionate ion will be formed on anode. Okay students, now let's see what will happen if we go for electrolysis of aqueous solution of salt. So before that, we should learn certain rules which will help you a lot in NEET. These rules are more than sufficient to handle any question of NEET, so please be careful with that. So there are the rules of electrolysis of aqueous solution of salt. First, whenever the water will be reduced, it will produce hydrogen. Very important, it will produce hydrogen, and also it will give you OH ions. So solution will become basic. When the solution becomes basic, pH will increase. Remember that, very important. Reduction of water will lead to increase in pH. Basic solution you will get. Whenever the water gets oxidized, you will get O2 and also H ions. That means solution becomes acidic. That means pH will decrease. pH will decrease. Solution becomes acidic. Okay. Now remember, this is very important. Normally group 1 cations, group 2 cation, metallic cations I'm talking about, and group 3 metallic cations and Mn2 plus, they are not reduced in water. Now simple as that, except these, rest all metallic cations can reduce in water. So which one? Group 1 cations, metallic cations, group 2 metallic cations, group 3 metallic cations, and Mn2 plus will not be reduced in water. Okay, so I'm trying to say that whenever there will be a competition, who will get reduced, so they will lose the battle. They will not accept electrons. Okay, they are very strong metallic in nature. Metals are known by the ability to donate electrons, so they will rather donate electrons and not accept electrons, so they will not get reduced. Now come, I said that earlier, except these, rest all ions will be reduced in water. Metal cations can be reduced in water. Now this fifth point is important. Chlorate, sulfate, nitrate, phosphate and fluoride ion, they will not be oxidized in water. The reason being, in all these anions, except this fluoride ion, the central atom is already in the highest possible oxidation state. Cl plus 7, sulfur is plus 6 here, nitrogen plus 5, phosphorus plus 5. So they don't have any electron as such, so you cannot oxidize them. They're already in their highest possible oxidation state till here. Now fluorine is the most electronegative element. It is almost impossible to pull out an electron from it and oxidize that. So it will not be oxidized in water. Now which anions can be oxidized in water? In general, chlorine, chloride, bromide and iodide, they can be oxidized in water. Normally I have told that sulfate will not be oxidized, but if we have a concentrated H2SO4 solution, in that case if we apply a higher voltage, sulfate ions will be oxidized to S2O8 2 negative by giving 2 electrons. So just learn them by heart and you will be able to solve any question of NEET. How? Let's see with some examples. Okay students, let's see some examples of electrolysis of aqueous solution of salt. So first we are taking aqueous NaCl electrolysis. Now remember that when I say aqueous NaCl, I mean that I'll be having Na plus, I'll be having Cl ion, and everywhere I'll be having water molecules. So I told you in the beginning that in case of electrolysis of aqueous solution of salt, water molecules will compete with the ions of the salt. So here you can see that Cl ions will go to anode, Na plus will go to cathode, the negative electrode. We are taking platinum, the inert electrodes, to work with. So at anode, what will be present? At anode, I will be having Cl ions and also water. Reason being, water is everywhere. Now at cathode, Na plus will be there and also water. Remember that when you are doing electrolysis of aqueous solution of salts, water will be present at cathode as well as at anode, and water will compete with the ions to get reduced as well as get oxidized. Now let's see this thing. In this case of aqueous NaCl, who will oxidize? Cl ion or H2O? I told you that Cl ions, Br ions and iodide ions can be oxidized in presence of H2O. So here Cl ions will be oxidized and water will not be oxidized. Over here, I told you group 1 metal cations, group 2 metal cations and group 3 metal cations cannot be reduced in presence of water. So they will not be reduced. Water will be reduced. Now let's see what will happen. On oxidation of Cl ions, I'll get what? 2 Cl ions will give you Cl2 and 2 electrons. These 2 electrons will travel all the way and they will be captured here by water. So water will get reduced. So these 2 electrons will be captured by water. Now 2H2O will accept these 2 electrons. So I told you the equation for reduction of water, it will give you what? H2 plus twice OH ions. So which gas is evolved at cathode? Hydrogen gas is evolved at cathode. Which gas is evolved at anode? Cl2 is evolved at anode. And solution will become basic. I'll also have OH ions and I'm having Na plus also. So the combination of Na plus and OH ions will give me NaOH. So during the electrolysis of aqueous solution of NaCl, I'll get NaOH. NaOH will make the solution basic. Is that clear? Remember that reduction of water always gives you hydrogen and makes the solution basic. Now come over here. Aqueous K2SO4. It will give you sulfate ion which will go to anode and K plus which will go to cathode. H2O will be present both at anode as well as cathode. Now let's see who will oxidize at anode. Will sulfate oxidize? No. The reason being, sulfur is already in the highest possible oxidation state. It does not have any electron to lose, so it cannot be oxidized. H2O will be oxidized. Now what happens when H2O gets oxidized? You know that 2H2O on oxidation will give you what? O2. Water on oxidation always gives you O2 plus 4 electrons. Now these electrons will be traveling all the way and they will reach the cathode. Now who will accept them? K plus or H2O? K plus will not, because it is in group 1. Group 1 metal cations don't accept electron. So H2O will have to accept the electrons. So H2O will reduce. See that H2O is getting oxidized and H2O is getting reduced as well. So when H2O will accept electrons, I have written that equation 2H2O will accept 2 electrons to give you what? H2 plus 2OH minus. But see, here we have got 4 electrons. So 4 electrons leaves anode, then 4 electrons will be reaching cathode. So we cannot have 2 electrons. We'll make it balanced now. So multiply this by 2. This will be now 4, 4, 2 and 4. So you can see now the 4 electrons are traveling and 4 electrons are being captured. So what you will get at anode, I'll get oxygen at anode and I'll get hydrogen at cathode. So when you do electrolysis of K2SO4, water will be oxidized, water will be reduced. I'll get oxygen at anode and hydrogen at cathode. In what ratio? You can see that these equations are balanced. I'm getting 1 mole of O2 and 2 mole of hydrogen. So I'll get oxygen and hydrogen in the ratio of 1:2. Now what will be the nature of solution? Basic or acidic? Well, it will be neutral. The reason being, we are having 4 H ions and we are also having 4 OH ions. They will react to form water. So solution will be neutral. Is that okay? So this is how we are going to handle the questions of electrolysis of aqueous solution of salt. Is that okay? Okay students, let's see the electrolysis using active electrodes. So we have got 2 cases and the most important one in front of us right now. So first one is electrolysis of aqueous copper sulfate solution by using copper electrodes. Now here these electrodes are supposed to get consumed or react during the course of reaction. So what happens when we use copper electrodes? Copper sulfate will give you sulfate ions and copper ions. Now as soon as you start the battery, now the copper anode will start dissociating into copper ions and it will give 2 electrons. These 2 electrons will pass through the wire and will be reaching at the cathode. But when the copper gives you copper ions, it gets eroded. So soon, slowly and slowly, you will find that this copper electrode gets eroded and the copper ions will start coming in the solution. Now when the electrons reaches the cathode, what happens? Here copper ions will try to capture the electrons and they will eventually be successful. So copper ions will accept electrons to become copper. Soon you will find the copper deposition at cathode. So if you take, suppose say, impure copper over here, what will happen? Impurities will settle down, copper ions will come in the solution and they will get deposited at the cathode. If you are taking a thin pure copper wire over here, you will find the entire pure copper because only copper ions are getting deposited. This is also called refining of copper by using active electrodes. Now come to second case. Electrolysis of aqueous NaCl by using mercury electrodes this time, very important. So we'll have Cl ions and Na+. At anode, these Cl ions will oxidize to give you Cl2. The 2 electrons will pass over here and they will be captured by Na+. Remember that here Na+ will accept electrons. Earlier in the case of aqueous NaCl solution by using platinum electrodes, the inert electrodes, Na+ was not getting reduced. It was water which was getting reduced. But when we have mercury as electrode, the potential required to reduce water is more as compared to the potential required to reduce sodium ions. So here sodium ions will get the preference to get reduced. Sodium ions will accept electrons, will become sodium. Now sodium has a great affinity for mercury. It will react with the mercury to form sodium amalgam, the alloy, and you will have sodium amalgam over here. Is that okay? So let's understand how to handle the questions on electrolysis. Okay, so the basic information first. One equivalent is nothing but charge on 1 mole of electron, and charge on 1 mole of electron is equivalent to 1 Faraday. Similarly, 2 equivalents will be charged on 2 mole of electron, which is nothing but 2 Faraday charge. Similarly, 5 equivalents will be equivalent to 5 Faraday charge. Okay, that means number of equivalents is equal to number of Faraday. Now understand, when we do electrolysis, suppose if A reacts at anode and B reacts at cathode, or you say that you are getting A at anode and B at cathode. Now when the electrons flow, suppose 5 electrons are flowing from anode, you will get 5 electrons at cathode. You cannot say that I am getting only 4 electrons or 2 electrons. The number of electrons leaving anode is always equal to number of electrons entering cathode. That means same charge leaves anode and that same amount of charge will be reaching cathode. When I say same charge, I mean what is charge? Nothing but equivalents. So equivalent of A will be equal to equivalent of B. I mean to say that charge given by A will be equal to charge accepted by B. Or you can say in simple words, equivalent of A will be equal to equivalent of B. Since the same charge is flowing, I mean that same Faradays will be there. 5 equivalent equal to 5 Faraday. So equivalent of A will be equal to equivalent of B will be equal to equivalent of charge. That means number of Faraday. Now see, if I simplify that, what is equivalence of A? That is nothing but weight of A upon equivalent weight of A. I can express number of equivalents in the form of weight of A upon equivalent weight of A. Similarly, equivalents of B will be weight of B upon equivalent weight of B. They both should be equal, and this will be equal to number of Faraday. Number of Faraday is nothing but current into time upon 96500. You all know this. Now I have a simple trick for gases, because many times while doing the questions on electrolysis, we find some gases are evolved. So for them, number of equivalent of gases is equal to volume of the gas evolved upon equivalent volume of the gas. Now what is the equivalent volume of the gas? It is the volume occupied by the equivalent weight of the gas at STP. Okay. Now equivalent volume of hydrogen and Cl2, where the valency factor is 2, the equivalent volume is 11.2 liter. You should learn this. I mean, this will be very handy, very helpful. Similarly, equivalent volume of O2 is 5.6 liter. I'll be using this and this frequently in the coming session. Is that okay? Now let's solve some questions. So guys, this is a simple flow chart which will help you in solving the questions on Faraday's law. So you have to reach to number of Faraday or number of charge. So this is the relationship. If weight is given, you divide by molecular weight or atomic weight, you will get number of moles. And if you multiply number of moles by valency factor involved, you will get number of equivalents. Now this part is actually about physical equivalent. This physical equivalent of the material should be equal to the electrical equivalent supplied, the charge supplied. So number of equivalents we have discussed that is equal to number of Faraday. Now number of Faraday is what? I into T upon 96500. I should be in ampere, time should be in seconds. Okay, and yes, obviously this formula will come handy. Number of equivalent is equal to weight upon equivalent weight of the substance involved. Okay, now let's see this question. On passing 1 Faraday charge through dilute solution of an acid, find the volume of hydrogen liberated at STP. Now here a gas is involved. I told you a trick basically to handle the questions of gases, that you know that number of equivalents is equal to number of Faraday. From there you know that this thing, important one. This is physical part, this is electrical part. So number of equivalent for gas is what? Volume of hydrogen, the gas, upon equivalent volume of hydrogen should be equal to number of Faraday. Number of Faraday is 1 Faraday. So I know I have to calculate volume of hydrogen. Equivalent volume of hydrogen is how much? I told you it is basically 11.2 liter. So here I can say that volume of hydrogen upon equivalent volume of hydrogen, how much? 11.2 liter should be equal to number of Faraday, that is 1. So volume of hydrogen evolved will be 11.2 liter. Simple as that. So this trick will save a lot of time of yours. Okay, let's come to second question. This says 2 Faraday charge is passed through FeBr2 ferrous bromide solution. Find weight of iron deposited. Now see, this ferrous bromide FeBr2 will give you what? Fe2 plus and Br ions, 2 of them. So valency factor of iron is 2 here. Is that clear? So iron ferrous ions will accept 2 electrons to give you Fe. So valency factor is 2. I am supposed to find out the weight of iron. So number of equivalents of iron should be equal to number of Faraday, number of charge passed through. So number of equivalents will be what? Weight upon equivalent weight, or I can begin by like say weight upon atomic weight of iron into valency factor should be equal to number of Faraday. How much? 2 Faraday. So if you put this value, weight upon atomic weight is 56 for iron, valency factor here is 2 equal to 2 Faraday. Is that clear? So this will be 2 will be cancelled. So I'll get weight of iron deposit will be 56 grams. Weight of iron will be 56 grams. Is that clear? Let's see a very simple and interesting question. This question says that 112 ml of hydrogen at STP is collected at cathode on passing a current through acidified water for 965 seconds. find the current involved. Find the current involved. Now they have given gas, and I told you that whenever a reaction take place during electrolysis, equivalents, so number of equivalents of hydrogen should be equal to number of Faraday, the charge involved. So for gases, I have told you what is that? Volume of hydrogen upon equivalent volume of hydrogen should be equal to number of Faraday. What is number of Faraday? I into T upon 96500. Okay, so volume of hydrogen is 112 ml. Now this is ml. This volume is actually 11.2 liter. This is liter, this is ml. Convert this ml into liter to make the unit same. 10 to power of -3 should be multiplied over here. Now this should be equal to I have to calculate. Time is given as 965 seconds upon 96500. This will be gone, this will be 100, and this will be 10. When you multiply that, this becomes 1000 into 10 to power -3 will be 1. So I will be equal to 1 ampere. So this is how you can solve these questions easily. Okay, now let's see one more question. So let's quickly see this question. This question says the current involved is 9.65 ampere. Time taken is 10 minutes. Weight of metal deposited during electrolysis is 3 grams. They are saying find equivalent weight of the metal involved. Now see, I know that whenever electrolysis will take place, I know number of equivalents of metal should be equal to number of Faraday of the charges involved. Now what is number of equivalent? That is weight upon equivalent weight. They are asking equivalent weight. Weight of metal upon equivalent weight of metal should be equal to number of Faraday. What is that? I into T upon 96500. Okay. Weight of metal is given as 3 gram. 3 upon equivalent weight should be equal to I is given as 9.65. Time is given as 10 minutes. You can see that. Convert this into seconds by multiplying by 60 upon 96500. Okay. So when you will solve it, you will find that equivalent weight is 50. It will be 50. Okay. So our next question is 40 gram calcium is produced in 2 hours by electrolysis. How much aluminium can be produced by same current in 2 hours? See that they are saying same current and in 2 hours. Calcium we got in 2 hours. They are asking aluminium in 2 hours by the same current. That means they are saying that I into T is same. Current, same current, time is also same. So I into T upon 96500 will be same for both aluminium as well as calcium. So if I say I into T by 96500 is same, that means number of Faraday is same. That means number of equivalent is also same for calcium and aluminium. That means I can say that equivalent of calcium, number of equivalents of calcium will be equal to number of equivalent of aluminium. Now what is that? That is weight of calcium upon equivalent weight of calcium should be equal to weight of aluminium upon equivalent weight of aluminium. Now weight of calcium is given as 40 gram. This will be 40 upon equivalent weight of calcium. Everyone knows that that is 20. Should be equal to weight of aluminium. We are supposed to calculate upon equivalent weight of aluminium is 9. You put that, this will be 2 times 9 into 2 will be 18 grams. So weight of aluminium I will be getting will be 18 grams. Simple. Okay guys, this is a simple and a good question. Find ratio of weight of gases evolved at anode and cathode on electrolysis of water. Now we have done it already that on electrolysis of water, at anode water will get oxidized and at cathode water will get reduced. On oxidation water gives you oxygen and on reduction water gives you hydrogen. So the two gases which will be evolved on electrolysis of water will be O2 and H2. Now I know that equivalent at anode is equal to equivalent at cathode. Why? Because same charge is flowing. Same charge means same equivalent. Okay. See now. So equivalent at anode is equal to equivalent at cathode. That means here we are talking about oxygen. Equivalent of O2 should be equal to equivalent of H2. So what is that with respect to O2 now? See that will be weight of O2 upon, what is the equivalent weight of O2? That is basically 8 grams. Should be equal to weight of hydrogen upon equivalent weight. Upon equivalent weight of hydrogen, how much? 1. So weight of O2 upon weight of hydrogen will be 8:1. They are asking the ratio of the gases evolved at anode and cathode. So anode and cathode. Now what I am saying basically, if they were asking you find the ratio of the volume instead of weight, if they were asking volume, in that case what you will do? In that case, simple as that, we'll do this thing. We know that equivalent of O2 will be equal to equivalent of hydrogen, but now with respect to volume, I know that volume of O2 upon equivalent volume of O2, equivalent volume of O2 should be equal to volume of hydrogen upon equivalent volume of hydrogen. So volume of O2 upon equivalent volume of O2 is how much? 5.6 liters. I have told you that trick. Should be equal to volume of hydrogen upon 11.2. So the ratio volume of O2 upon volume of hydrogen will be 5.6 upon 11.2, and that will be equal to 1/2. So whether they ask you weight or volume ratio, we can do that with ease now. Okay. So let's see this question. This question says that in an electrolytic reduction of nitroarene, they have not given me the exact formula of that, and I do not need that actually. With 50% current efficiency, this is important because people do mistakes over here. 50% current efficiency, 20.5 gram of the compound is reduced. That means 20.5 gram of nitroarene is reduced on passing a current which is having a 50% efficiency. Is reduced by 2 Faraday electric charge. Find molecular weight of compound. First of all, understand, they are saying that total amount of charge passed is 2 Faraday, and this amount of current is having a 50% efficiency. That means out of 2 Faraday, how much of current or how much of charge will be passing usefully? That will be 1. So if you see that 2 Faraday having a 50% efficiency will result in 1 Faraday charge. So effectively we are having 1 Faraday charge, not 2 Faraday. This charge is not completely utilized, it is wasted somewhere. So we are ultimately getting only 1 Faraday. Okay. Now I know that they are saying find molecular weight of the compound. I know that number of equivalents should be equal to number of Faraday, which is like weight upon molecular weight. They are asking molecular weight, so I'll put molecular weight into the picture. Into valency factor, weight divided by molecular weight into valency factor is equal to number of equivalents, should be equal to number of Faraday. Number of Faraday is how much? It is basically 1. Now in this question I need valency factor. How much of charge is involved? How many electrons are involved in reduction of this compound? Now see, this is nitroarene. On reduction of nitroarene, I'll get a nitroaniline kind of thing. Now let's balance that to find out number of electrons involved. You see that 2 oxygen are gone, rest all is balanced. Now I should balance oxygen. So 2 oxygen will give me, 2 H2O. To balance 2 oxygen atoms, I should add 2 water molecules. Now see, 4 hydrogen atoms over here plus 2 hydrogen atoms here, total becomes 6 hydrogen atoms. To balance 6 hydrogen atoms, I should add 6H plus. Now everything is balanced, every atom is balanced. Now my task is to balance charge. See, this part is neutral, there is no charge. Here I have got 6 positive. To neutralize that, I should add 6 electron. So 1 mole of this nitroarene is utilizing 6 electrons. So valency factor will be 6. Okay. So weight is given as 20.5. Molecular weight I have to calculate into valency factor is 6. Number of Faraday is now 1. So molecular weight will be 20.5 into 6, that will be 123. So molecular weight of this compound is 123.